something I would say is quite critical, especially in Hong Kong. Typical this kind of construction worker is about 50 years old, so that not too many students like you want to work as construction workers. So in this case, is a big issue. It is locally for Hong Kong construction industry. Actually, in mainland China and many other places are probably facing the same problem. So anyway, I would say this is one of a very special opportunity for our students to understand about this kind of issue. And of course, we have been successful to have a series of the kind of team to work on prototype for this kind of automation robotics for industry. And at this moment, at this around last December 2000 last year, right, we do have 3 start team spin off, right? So it's not normally we do only the kind of basic research. We have 3 spin off company, and of course today we are very happy to invite Dr. Yuan to give the guest lecture. Of course, Dr. Yuan's background is, I would say, I already sent you this kind of biography. A background is on civil engineering, especially is an expert in geomechanics. Actually, he got a PhD at MIT under very, very famous professor in this kind of geomechanics. So that, and of course, he had been working on the construction industry in the United States for about 5 years, and then joined our HKCRC and very senior researcher to supervise a team about the kind of how to come with the kind of new technology. So that I think without further ado, that welcome Dr. Yuan to give this kind of guest lecture. And of course, please note that this lecture is open to not only our ME this course, but also for maybe I also send the email to the other our UG MA student as well. Okay, so okay, now I let Dr. Yuan to give this kind of special guest lecture. Okay.
Great, thank you, Professor Lee. Wow, that's quite a detailed introduction. And good morning, everyone. Great pleasure, my great pleasure to attend this, to give this lecture. And actually, I recall last year we had a similar, but it's always my pleasure and to give a lecture to HKUST. As many of you may know, actually, we are HKCRC, stand for the Center for Construction Robotics, and we're also part of the HKUST, but we located in Science Park. So we seems like we are the other part of the UST, and not a lot of people know. We do some cool stuff here. So I'm a civil engineer, and as Professor Lee mentioned, I did some conventional practical engineer back in US, and I got a PhD in pure mechanics things, but fundamental. I'm a researcher inside, so I want to do some innovative things. So I joined the Construction Robotics Center back in 2021. Actually, we started the journey actually with Professor Lee, and all together we really appreciate all the support along the journey here. We start. So at the beginning, we thought we are doing some pure research, but here in the science park and in this facility, actually, we can make our research and from research become a product and make a real impact. So that's what I really want to share today, and to see if I can spark some interest, and hopefully there are some job opportunities, and we can collaborate in down the road. So well, I give the topic of future construction, as these slides actually we used, and we give the similar topic to some of the investors from Saudi Arabia several days ago to try to draw some attention. So you may find there are some things quite like imaginary part, but hopefully you can get some ideas on what we are doing. As Professor Lee mentioned, we are one of the researcher center under the HKUST, but were founded by this InnoHK program, which I imagine this is a quite ambitious program and funded by government, and they established 28 institutes and doing all kinds of innovations. And UST, actually, we had the chip center, and we are another center, actually the only one center among all the 28 focusing on construction industry, focusing on how to use robots and to help the construction. And yeah, so the global, the ambition or the vision of Hong Kong is trying to make this city to be an innovation hub and to facilitate all the cool stuff. And we are the pioneer and in this construction, this very neat area. So we founded in 2020, end of 2020, and actually I joined very beginning in 2021. And we are actually a joint researcher as a joint research institute that many may not know. And we are several professors come from UST and advise us. And there we also had professor from UC Berkeley. Actually, one of the professor, Roberto Horowitz, he's sitting right across the hall with us, and he's taking sabbatical and giving several of the advice and chatting with us every Wednesday and to see. So it's a great opportunity to collaborate internationally and to chatting on the new ideas and making the robots here. So that's a great opportunity here. And of course, we are not a pure research institute. That's a unique part about this center. We collaborate with practical practitioner. Several of our early collaborators, including China State, the CSEC, China State Construction Hong Kong part, and international part. And they are the big player here. And some of you may know they basically helped Hong Kong to build all the isolation facility during the COVID time. And now they also moved to the North metropolitan area where Hong Kong will build 300,000 public housing units there, and they're one of the big contractors. And we also have Si Hong Kai, who's a developer, and they also give us, they also shared quite a new ideas on how to promote the innovation in tower crane and in the safety measures. So we had a lot of conversation, and from there we can get a new idea on where's the pinpoint in this industry and what type of technology we want to develop to help them. So there's strong collaboration, and of course there's a government, the CEDD, there's all the other players. So together we want to form a joint force, a joint research hub, and to build a world-class technology centers and to use the robotics, the computer visions, the computer science, and AI things to improve the construction and to upgrade this construction industry. Yeah, and as Professor Li mentioned, we our center director, Professor Zhe Xiang Li, who is the professor from HKUST EC department, but also he co-founded a series of startup, and he's really like the founding father of all the whole innovation systems here. And we also had mentors and Professor Li from this lecture, and also Professor Roberto Horowitz from UC Berkeley, Professor Ma Yi from now he's in Hong Kong U as our AI expert, advise us. And the vision, our center trying to picture ourselves is we do innovative research here. We build a research prototype. And meanwhile, we also want to find the pain points in the construction industry. So we meet their desire, we meet their need, and to use to tweak our prototype and to continue iterate until we can use them in the practical field. And then we spin off the startup and to commercialization. So we really want to make this pipeline to from the research to the field to make a real impact into the construction industry. So here we can we imagine ourselves as like a biolabs or IBM centers who really reshaped this whole the computer industry, and here we want to do the same thing for construction industry. That's, well, a little bit brag about ourselves. Here we're not alone, of course. We have an innovation system, and thanks to the HKUST networking, and also Professor Zhexiang Li had several of the innovation centers in mainland. And as you can see, there's a whole map. If you can imagine, this is the chessboard. We are one piece that located the south in Hong Kong, but we have a whole army behind us. Like we had export park in Changsha, in Ningbo, and in Shenzhen, and in Dongguan, of course, and we also got fully support from the Hong Kong CIC, the Construction Industry Council, who really promoting a lot of new innovation in the construction, and that also reveals the ambition, the determination from Hong Kong government. So really had a good relationship, and they also come and visit us and saying when your products gonna commercialize. And we also, it's our great privilege, our great honor actually. We signed recently an MOU agreement with the Hong Kong Government Housing Bureau, and they really open the door and give us all the opportunities on trial our products on their public housing projects, and also give us all the new ideas on how to improve our products based on their project's needs. So we are currently had 2 projects ongoing with them. And we also promote our products overseas. Of course, we recently had a NEOM projects, the very huge and ambitious project from Saudi Arabia, and several of the guests coming to Hong Kong last week. And we delivered several of our products to mainland, to some contract developer in mainland. So we had a whole system coming. So that's our resource. Oh, okay. So this is our roadmap. Our research really focus on a wide area that spread out basically the entire chain of the construction industry, from the design, where the engineer put their ideas into the drawing and to make these things document, and to make this become model that can communicate with engineer from the design. And the center part is action part, where we want to build tools, the digitalization tools, the hand tools, the inspection, or even the moderate size of single task robots, and to help the construction workers to do their job in a much safer, more efficient way, and to help all the individual construction tasks. And the third part would be the system, the solution. After we build all the individual robots, all the technologies, we want to connect the dots to make a whole set of solutions. For instance, we can help the whole tower crane operating. We can help the prefabricate construction in the factory. Actually, that's a quite modern way we are doing in Hong Kong. So we trying to pinpoint our research throughout this whole pipeline, the whole chain of the construction industry. And to be specific, actually, we had several of the products that can be categorized through from design to action to the solutions. I will share some of the projects I came across over this past 3 years on several things. For instance, we have AI design engine. That's from the design part, where everybody knows all the ChatGPT, but back then actually we spot the generative design actually can really help the construction the architecture designer, the engineer design, and to help them to make their idea come to the design drawing in a much faster, more efficient way, so that we can facilitate communication. And intelligent detection, that's a part where we see after design, when we want to make this more detailed drawing, we need to collect data, we need to do inspection, we need to do the survey and mapping, and that's the data part. And then come to the action part, where we have single task robots, as I will show you and you will see later. We have a rebar tying, we have the wall panel moving, transportation, ground grinding, all the several things, and just a few, just the tip of iceberg things here. And if you want to see, I strongly suggest you come over and here Science Park and to see in person, and we can have a lot of chat. And then there's a system. We build our solution. Currently, actually, we want to facilitate the prefabricated manufacturing. And there are several of them. Oh, actually, there are several ongoing projects in Hong Kong. They are building their modular units, basically a container or a single house unit back in the factory in Shenzhen, in Guangdong, in Dongguan, Jiangmen, offsite, not in Hong Kong. They build their modular units in the factory, and then they transport, they shipped the modular units one by one, like a Lego block, and come to Hong Kong, and then transport through the truck to the construction site in Hong Kong, and use the torque crane to lift and to pile them one by one. So that's a new way, the new modern way of doing the construction in Hong Kong. They call it modular construction in Hong Kong. So currently, we're trying to see if there are any innovation that we can apply in those factories and through the transportation or the on-site, and to see if we can facilitate this new, very cool modular construction way. So hopefully one day we can catch up with all this Xiaomi, all this now those automobile industry. We can have a dark factory. One day we may have our dark factory here in construction site for the modular construction. So there are several of them, the application that I can share one by one. The last part, energy and materials, ESG, yes, there's a lot of ongoing discussion or even action plan in Hong Kong. We also watching closely with our industry, but currently our research is still in school, and not much I can talk on this product side. But yeah, we do have some research collaborating with a professor at HKUST on this area. Yeah, sure. Let's jump into some real meat here. So the AI design things, back in 2020. We do see there are the generative design, generative AI model that are coming that can really help language generating. But here we're trying to generate the picture, generate a SketchUp, the sketch or the drawing. And so here at HKCRC, we had one of the product that can help the interior design architecture, and to use their drawing and to rendering into different style of the interior design, the final finishing. So here the platform actually showing that if you just provide a sketch, a pencil drawing, and or even just a picture that you took from your cell phone on any site, any interior room, and you say changing this style into a classic, into a modernized, simple fashion way to decorate. So this AI engine actually can generate the style drawing for you. And so we can use this tool to help the designer to convey their customer, saying, hey, is that style that you want? And if not, we can easily or quickly adapt and changing the styles. And currently this tool already online, and we are also tweaking and to find our potential customer here. And the lower, that's upper part corner, that's AI design. The lower corner actually is another, it's not the interior design, but if we had layout drawing, let's say if we want to design a building, and now we want to fill in the wall panel to divide the room into different zones here. So the construction actually, the contractor will use a wall panel to divide all the different area, but how to put those wall panel and how to make count how many wall panels we want and to make this the layout to optimize, this is called the detail design. So here we also designed an engine to help the detail designer and to make their wall panel into a more economic way and to make this optimization approach in a more efficient way. So this is a detailed design engine. Of course, we also used several of the optimization algorithms behind, and that would be broadly categorized as an AI engine here. And this actually, we already got some of the commercialized customer. And the best part here is the same team, actually, they also built a robots to move out of the wall panel and to install the wall panel. So they really had a pipeline here. So they are one of the spin-offs from the center. So I really say to congrats to them and to see the successful in these products. Oops. Okay, so that's the design part, and just quickly jump. And now come to the data part. Here we actually some of you may see this familiar. This is HKUST. So we trying to build a pipeline to use a drone to collect data and to help engineer to do inspection. So this is data part. We test out actually we found our pilot case in HKUST as there are several buildings that are open and we can fly. And what we want to do is we want to first use our drones to do photogrammetry and to do the reconstruction of the whole campus. So now we can have a survey, we can have a whole what we call digital twin. That's a long way before, that's 2020. And then the second phase is we can fly the drones facing directly to this facade and to do this facade inspection and to see if there are any cracks, any leakage, or any potential defects. So we use this the drone-based mounted the RGB camera, the wide angle lens, and also we use the infrared camera and to see is there any the thermography, any abnormal from the thermography. If there's some thermal contrast then during the daylight, and then we can spot maybe there's a leakage because there's a response and differently in this thermography. So we build a really a pipeline here, and I'm aware that several team actually they can do the same, but we are the we were the pioneers, several of the pioneers back then. And recently we also got several collaboration with these the housing and also with several company in mainland. They're really interested in this technology, and we will see if they can buy this whole pipeline or we can provide a solution to them. Again, it's still in the data part. So we also built some device. So this is what we call the displacement meter. And you may see this as a total station. sometimes on this on street, and people using total station to do survey, to measure distance, to measure the horizontal distance height. But the total station can also be used for monitoring the settlement or the deformation movement in millimeter level. But the total station, on the other hand, is quite expensive. So we want to build a device that can use not the laser technology for total station, but we use the computer vision, the camera technology, and to make the monitoring to be a simple, reliable way, and also economic way. So we, after several years, we built a prototype, and that just using one camera, an infrared lens, and with a target that can be installed along, let's say, excavation site or along a bridge. And we use this camera to see the targets and in this thermographic, and to really to analyze the pixel level movement. And we can monitoring the deformation in millimeter level. So this is one of the sites actually in the near the Shenzhen border. We installed 2 of the targets and 1 camera 15 meters away, and we really monitored this deformation. This is a horizontal deformation, but we see actually there are deformation, and that deformation really influenced by the daylight and the temperature effects. So we show this data to the contractor, and they're really surprised and impressed, and they say, that's really some tools that can review more data and give them more insights, and they want to see if they can use more of this camera and to do some large scale monitoring. And of course, we can use the same technology to the bridge, to the in the tunnel, and in Hong Kong, we also have a lot of slopes, and to see slope monitoring. So that's some new technology. And the best part, the sweet part, is the cost of this camera actually is just 1/5 of the total station. That's really attractive to all the contractor. We only build this tool specifically for monitoring, and we use a low cost technology, but still can maintain the same accuracy and reliable level. So that's I would say a sweet spot for a new product. So we made it. Okay, so there are several of the individual robots here. So there are actually each video represent one product. So on the left, I can just introduce one by one. On the left top left corner, there's a LiDAR device that mounted on the 2-wheel robots here. So what these robots can do is based on this LiDAR and this video capturing device, that we can collect this point cloud while navigating through this construction. And so we can capture the whole 3D model of the construction in about 15 minutes or half an hour. This is really an efficient and accurate way to do surveying. Normally, if the engineer wants to do a surveying, either use a total station or just use a hand drawing to navigate and to go through this whole construction site. It's very time consuming and low efficient, but also the data collected is very sparse. And here we can collect the thousands, millions point clouds, and can document all the details of this construction site at current moment in just 15 minutes. And so we can use this type of technology to do construction progress monitoring, to do inspection, or even just to get a whole model of the construction to communicate with the clients. There are several advantages offered by these products. Okay, on the top right corner here, this is a platform actually, as I mentioned. after we collecting all the point cloud, or if we fly a drones and to do this photogrammetry and to do 3D reconstruction, and what we can use for this model. Here is a platform that we built here in our center, and we can use this data point cloud and communicate with the contractor, or have the contractor communicate with their clients, with their developer, to see, oh, that's the progress we have been built up to today, and what's the next plan. And we can even yes, we can even import the beam model, the mesh, the wireframe, all the lines, the nodes, and to overlaying on our point cloud to see how that's the next plan. And you see we can do this very neat comparison, the beam model with the point cloud, and to see is there any a contradiction, or are they in compliance, and to make this really a nice visualization and presentation. So this is the tools that we offer. And I want to mention this is the second company actually spin off from this center, and they really specialize on the digitalization and the visualization to help a contractor to communicate and to to generate the value through these tools. And the bottom left, that's the robots. Actually, I mentioned about the wall panel moving transportation, and also the wall panel installation. So this is the Zoe, our team. They called Zoe, and they also is a spin-off team, and they built two robots. One is moving, and this one currently showing. This one is moving. So each wall panel are about the 3 meters long, or even longer, can be 6 meters long. And the moving robots actually can lift about 3 or 4 of those wall panels in one run, and each actually can weigh about half ton. So it's really a heavy transportation. And current practice, or typical practice in construction site, is 3 or 4 construction worker and using a hand truck to lift and moving all this. It's dangerous. It's very not I mean, an easy job, and also sometimes they can make damage to the wall panels. So the contractor asked us, can we build something automatic? And one construction worker just using a remote control and just moving the wall panel by itself. So yeah, we built this transportation. And then the second phase, can robots that can pick up this wall panel and install and rotate and put this in place. So each wall panel can also requires 3 construction workers to lift and install. So we built these 2 robots to really simplify this moving and installation process and reduce the construction workers to 2, and to improve the efficiency, also the safety, no need to mention. And so this team actually spin off, and now they work in Dongguan, and they also received several of the order of this installation construction. So the bottom right is another robots, we call this floor grinding and grinding robots. So floor grinding is another very heavy and dirty job in construction site. Not a lot of people want to do that. As you can imagine, while you're grinding, that generates a significant amount of dust and the dirt, and it's barely can smell, barely can breathe over that period. So being there and watching all this process is really not ideal construction environment. So here we build a robot to make it automatic way. So we had several features. First, we can make it to automatic grinding while navigating. And we also had a vacuum machine back in this down in the corner, and to really reduce the dust generated here. And the second part is we can control how much the grinding these projects need. we use a laser and generating a height of level and to send the signal to this receiver. So the receiver controls the grinder how much to push, to press on the ground. So we can really grind this in a very elegant way. So the accuracy actually this team can control is within 1 millimeter grinding over about 2 meters distance while it's moving, while it's navigating. So this grinding machine is the really one of the typical example that we can build several advanced machine that can help changing this construction environment to improve the construction environment and also improve the accuracy, the quality they build. So this is really what the construction robots can offer in this area. Okay, that's several of the construction and robots, and let's move to, this is one of the robots that we're currently still working in the center, but already attract quite a lot of attention. So I give this to a single page here. So this is called rebar tying robots. One of the reason that we pay a lot of attention is the rebar tying is one of the most expensive job paid on construction site, and based on the salary, the survey, I heard they paid 2,500 per day for a construction worker in Hong Kong, not in mainland. Mainland is just another story. But here in Hong Kong, just because the working environment directly under the sign, and you are using just a thin wire to tying all the knots, but one by one, and working whole day, it's really an intensive job, and easily get the heat stroke will reduce their working efficiency. So they paid really well. Not a lot of people want to do this job in the daytime in Hong Kong. So several of these rebar tying company actually asking us, can you use your robot technology and to help? So we say, yeah, we specialize, and we can customize several of the mechanics to tying this rebar. And I have to say, it's not easy job. We found first tying a knot, it's fine, but the tying 100 of them and not missing one, that's not easy. And another thing is you want to make these robots to be reliable working on the construction site. It's not easy. So we come in several ways. So first, in the lab, we test several of the rebar tying guns mechanism. We disassemble it, we analyze it, and we found what's the best mechanism that can tie in the lab. And then we build this walking mechanism that can really use the rebar as the trail and to walking over on it. And so these robots can walking and tying one by one. And then we test it on several of the large area of the rebar web in Dongguan, and here in Hong Kong, we don't have enough space. And it currently passed the test. So now this robots, I heard it's moved to the DVT, from EVT to DVT phase. And now we really want to give them a try, and in several construction sites in Shenzhen. So yeah, wish us good luck. But there's some recent progress about this project. Is we also pitched this idea. We present into this Geneva the invention exhibition actually weeks ago, and we got the gold medal. And several of the jury panel actually saying, hey, that's a quite interesting robot, and when you guys can make this happen. We answer soon, very soon. Yeah, so that's the robots. That's the single task robots, and we also built something. Yes, not working on the construction site, the outside, the outdoor, but also some robots can be used in factory. And as I mentioned, one day we may build a duck factory here in construction industry. So this is one of the construction industry, the factory, and they're building a wall panel. And here the wall panel actually, it requires first, it needs rebar tying and to make a web. And then it's pouring the concrete in, and then of course it needs to lay the forms and pour the concrete in and to make these the wall panel smooth. And also we after wall panel being built, we can use our robots to move and to make it to the next phase and to curing the concrete, and after curing it can move to the site. And so here has several phases. One is rebar tying, we can help. Another is we also build several inspection AI camera that can measure, mounted on a frame and shooting either using structure light or using stereo camera, the image to measure the dimension of all this wall panel, and to check with the compliance, to do an inspection report, and afterward we can do the logistic, the transportation. So we are currently pitching this whole a new idea in several of the factory in Shenzhen, and not only for wall panel, several of the factory actually they build a wall panel, but also they build the modular housing and to make this called modular integrated construction in Hong Kong. So several factories interested in these whole solutions, and they're discussing with us, and we had some ongoing projects here. Okay. Let's see. Oh, this is one of the video that we made and to explain what we can do here. So as you can see, there's robotics arms, of course, a frame, and we can also build a frame and do the inspection for the next phase. And several of the phase actually we can apply our innovation in. So the robotic arm control, I haven't mentioned, but this is one of the expertise of the Professor Roberto Horowitz from UC Berkeley, and he really shine some interest insight on this, and seeing several of the robotic arms control actually can be optimized using AI model, using the transformer, using the diffusion-based model, and actually can do this automatic control. Using AI-based, the learning-based control can reduce the training process and facilitate their the deploy time. And here the inspection, actually several of the stage, actually we can use stereo vision and to measure the length, and can measure the layout basically of the wall panel, and then they can move to the next phase to assemble this so-called modular housing, the construction. So that's the new solution that we propose to several factories here. Yeah, that's the factory side is one of the I mentioned system solution that we provide to the to several contractors. Here is another systematic system solution that we propose. It's a tower crane. The tower crane is another area that we focused very intensively on this. So one of the tower crane issue is while the Hong Kong continually facing the lack of operators in this operating tower crane, and because all the operator, they have to climb on the tower crane and to stay there for the whole day. By whole day, I mean no toilets, nothing. You eat, you do whatever on it. So not a lot of people want to do this tower crane operating. So we are proposing, hey, can we do something cool like remote control? Remote control, that's what we built here. So we had an operating platform. And on the other side, we built a tower crane model here. I would say that's the largest tower crane, indoor largest tower crane model here in Hong Kong. So we built here, and the back behind the scene, that's the operating the platform. And as you see, there are 6 axes. We can make this platform to move, to really mimic the operator on this tower crane. And another challenge they're facing is, since the Hong Kong construction really want to use the modular housing, so each modular unit weighs easily 20 tons or 30 tons if you made it in concrete, in material. And the concrete, the block actually really makes this operating, the lifting tower crane very challenging. Is there, especially when there's a strong wind, so is there any safe way or even intelligent way to operate to lift this block, is what the construction industry asking us. So we imagine, hey, since there's a more autonomous cars, can we make a tower crane to be intelligent, to make a, let's say, L3 autonomous tower crane? Can we make this happen? So that's the second phase. So first phase, if we want to make a remote control. The second phase, we can make autonomous L3, or the really intelligent tower crane. So that's the 2 areas that we are working that require several skill set. One is remote control. Then we have to figure about to figure out the communicating and the control, and also the delay, and also the perception. The perception, if we want to transfer what the tower crane can sense using the LiDAR, using the 3D camera, and transfer all this image into on the screen on this operator platform. And then that's the remote, to make this remote control happen. And the second phase, if we want to use L3, of course, we need the path planning, we need perception, we need all the things, and also we need to train this tower crane model to realize what's really surrounding, and to use the path planning or the collision avoidance to make sure the navigating to transport this modular unit to navigate safely, to avoid all this critical area. And the third, and also we can use the path planning to save the energy, to make it more energy efficient and safer. So this L3 intelligent tower crane really opened quite a lot of imagination of the area. So the housing authority or the housing bureau actually really interested in this technology, and also several of the Xinhongkai, all the companies were asking, hey, is there any collaboration or when this happen? And we also proposed this to the Saudi Arabia, to the NEOM, and to see if you want to build something mega projects in Saudi Arabia, you may face a similar challenging, the operating, the strong winds, or the safely. And if we can make this intelligent, hey, you may have a better solution for. So yeah, that's one of the systematic. I can replay this video again. One of the systematic solution. That's phase 1 remote control. I have to say that that's quite fun to play and to operate on this. It's really like to playing like a roller coaster in Disneyland, but yeah, we're working. That's our job. And that's the point cloud we applied, and this is the tower crane model. We really we actually put a much larger LiDAR and video camera on a real tower crane in Caihong, in that in the construction side, housing bureau currently working on. So we really had a tower crane model. That's the second phase. That's path planning. That's to make these things smart, to make it operate, so that we just tell from the point A to point B, the tower crane can really lift and make these things happen by itself. So we had a tower crane model, but we also applied this technology on a tower crane, on a real tower crane already. Last week, one of our engineers climbed the tower crane, of course, with all the safety, with the harness and all the safety measures. But we try to combine what we do in our laboratory and to apply it on the real side. No, that's the rebar tying robots. Oh, I don't know why I put this video here, but that's another video I forgot to play. So here is the rebar tying. This is a video that we shoot in the second phase in the lab, so we can make these robots hands off. We will make these robots tying about 40 or I don't know how many, 100 tying knots, and it can make a straight tying. Yeah, so the numbers is 500 knots per hour. That's pretty good. And imagine that these robots actually can work 7/24, right? And so we really don't have to go out and do that manually. Yeah, that's pretty much. I don't have to go through all this. Okay, yeah. In summary, actually, we trying to build several tools, individual robots, and we also want to build a system to connect all these. And together, as you can see from the several of the areas, several of the spots, if we connect it, then we can upgrade this whole system. So HKCRC, actually our center, really dedicated on making several very specific products, but then we combine them and to make this whole solution and to change the whole industry. The left part actually showing several of our typical projects here, products here. And yeah, so there are some, this already mentioned, we have several of collaborating. We went to expo exhibition, went to the exhibition and the seminar workshop, and also deliver our products, and yeah, several activities. So, the last part I want to mention, well, all those things will not happen without the talent people. And here, as you see, that's several of them, the summer camp, we held over the past years, and several, I see several still here and several left, and we are actually quite a lot actually from HKUST, and we first recruit as an intern, and then they work here, and some, well, get their products funded and spin off. So that's really a pipeline here I want to share. And not only summer camp, I mean, by summer camp, it's really not a camp. We really send people down to the construction site, and we investigate, we interview our construction worker and to gather feedback, and then we work our prototype day and night. And it's like a competition, but we really compete with ourselves, and we want to make our product work. And we after prototype making, we share, and we share through the Zoom meeting with UC Berkeley professor, with all the people, and to get their feedback, and eventually we validate our products on the real field. Yeah, that's well, I want to mention we are still opening, and that's all the opportunities. We in over the summer we had several of interns, and I if anyone interested, I really appreciate if you can drop a resume or email or follow us on our WeChat on the as you can scan the QR code here. And our interview generally will start online, and you're all also welcome knock the door and in person and to say hi and to check out what we're doing. And the intern probably start from June and or last until August. So that's really a good opportunity, and to spend the summer with us and to, yeah, let's make something cool here.
Okay, thank you very much, Dr. Yuan. I can see that compared with last year, we have a lot more activity.
Yeah, we do have something new here. Yeah,
it's very amazing to see we have a lot more activity and project. So of course, I don't know if any student had some question for Dr. Yuan for this kind of Hong Kong CRC, especially for those some intern or some can or some additional information. So any question for Dr. Yuan? Okay, but I do have question for you because unfortunately my hometown Taiwan suffered big earthquake on 3rd of April, and now actually yesterday a big earthquake of 7.3. So I said want to ask you how you can really, once a big earthquake, and first is any way we use advanced technology. First is the early warning system, right? Once a big earthquake, before if really so bad, then we have to get out of the building. There's something avoid some people die. Unfortunately, actually there's a big earthquake when I was student, right? In they call Taiwan 921 earthquake. About happened in 1999. About more than 2,000 people died in Taiwan, including my classmate's father. So I just want to, on behalf of my classmate and all my friend in Taiwan, can you give some advice? First is any kind of a new technology, AI or sensor, for early warning for earthquake. That's a big issue. And also, second thing, once a big earthquake, how we look at the design, right? Design of a building to maybe more resistant big earthquake. I would say it's not in Taiwan, Japan, somehow in recent several months. Wow, we have global so many earthquakes, including New York. So it's a big problem, global problem. Please give you have a background in civil engineering or on this kind of Hong Kong CRC. I probably you're the best person to give this kind of information to everybody.
Wow, that's thank you, Professor Lee. Yeah,
it's a real problem.
It's a real problem. I
admit.
Not
my hometown Taiwan, but you see, again, my classmate, the father died in.
My condolences.
I do remember. That's why I do want to get your this kind of most updated advice.
Sure, that's very tragic. Actually, I have to say, my wife actually was in Taiwan last week and really experienced that earthquake in person, in sequence. That earthquake last almost the whole night. It's quite unusual to see. So actually, she just raised the same question. Yeah.
After the earthquake, now actually since that earthquake on 3rd of April, they already have 1,200 earthquake aftershock. So
yeah, we saw the sequence. It's really astonishing. It's just an unusual. The earthquake. After the big one, the major one, there's some residual that continue, and it's lasting like nonstop. It's something unusual here. I'm sorry, I'm not earthquake engineer. I do have a colleague, and actually the best earthquake engineer, I would say, the Summer professor, very nice, from UC Berkeley, and they really work on that. As you can imagine, the California, they were on the 4th zone, right? They really face a very challenging issue. Lucky here in Hong Kong, earthquake is not a major issue. We do not sit on the fault, the active zone here. But in Taiwan and Japan, unfortunately, they're facing the challenging. But one of them, so for monitoring, monitoring our early warning earthquake. It's really challenging, still one of the most challenging, not only in civil engineer, but also in the human, all these nature science. We do not currently have a very successful way. Only, let's say, if we put more sensor, we may pushing this early warning into 30 seconds or 1 minute and into more like rapid way. But I would say make it to 1 minute early warning really useful. It can make people to have time to hide or to protect themselves in a safe way, in a safe space. Just run to the basement or run into some area with cover would be really useful. So that part, I would say, with sensor, with all very high frequency vibrating all far away across the city, that's what a city scale, smart city scale technology can help. And satellite may also have some early warning sign. Let's say NASA really worked on some of the satellite image data analysis to see if there's some abnormal from a larger scale, like fault zone or something. But that's really beyond robots can do that. That's really a scientific advance in there. But for us as a construction or civil engineer side, since the science may not provide enough early warning, then we really want to make the protection side to be reliable. So here in Japan, I have to mention that the modular construction here we install in we are implement in Hong Kong currently actually has been in Japan. They had a long experience using modular construction to use this block by block, and quite a lot of people asking, are they safe? I mean, you just piled them piece by piece. But in Japan, they had a really unique technology. They call this pre-stress tension, and in fiber, and to connect all these the modular and the pre-stress pre-tension all this the cable, and to make them to connect a much safer way. So I'm quite actually interested to say that my pleasure to say in HKCRC we do have one of the research topic actually to research the connector between the modular block and to make it to sustain the earthquake. Strong wind is what Hong Kong really facing. Earthquake is not, but strong wind is. But same technology, we can use the pre-stress, or we can use some very uniquely designed bolt nuts and to connect all this modular block one by one and to make it reliable. That's what we can do. That's what construction and all the robots actually can help us and to do and to make this design more reliable. So last time I checked, though all those connector design actually are really ongoing research. The CIC funded, and there are some companies that really actively research on what type of connector, and their perspective is to make this connector robust, reliable, but also cheaper. And to if you can use one knot, then you don't need to make it two, right? So so that area, our center also has several researchers actually from Chongqing University. They use a beam and they use connect with a finite element analysis to make the pipeline to optimize all this design. So they're currently working on that. It's quite an interesting research too. Yeah, just to share some insights here.
Okay, thank you very much for your this kind of information. So I still hope that some students can ask good question. Huh?
Sure.
Any question? No question at all? Of course, I probably still I want the student to do some survey, doing that, so that that is something I don't know if yeah, I just try to do some survey, especially this kind of thing, so that at the end I do hope that you can if you're interested about Hong Kong CS world, can you try to fill this kind of our Zoom polling for this special online seminar, so that I don't know if they, let me see if I can launch or not. Somehow it doesn't work. Have been launched. Can you I don't know if you are able to look at that Zoom the survey. Yes or no?
I don't have access to the survey result, I believe.
Strange. I cannot click here. There must some. Anyway, maybe I should copy that. I don't know why it doesn't.
But I do have a question. Actually, there are.
There's some question.
One question here. Yeah, some question. Taha's asking. Oh, the part-time role here.
Also a part-time role during the semester.
You mean the part-time intern in the semester, not in the summer, right? Yeah, we have intern in the semester part-time, and during the semester the intern will only allowed to work 2 days per week, I believe. I recall. That may, yeah, we had two intern currently, and well, that intern we may not have let's say quite a long focus task for the interns. Sometimes they were just doing some let's say trivial jobs and doing, so it's basically because of time. If we want to give them some really challenging time, and only working 2 days per week is not enough, and well, the whole development progress may be dragged due to this insufficient time put. So I would say we will still have intern in the semester. You can come and talk and with us, but well, that intern job may not be as important as you think. If you want to come and check and learn, it's fine, but it may not be that successful of you accomplish something, and yeah, just during the semester, just because the commitment. That's my personal experience. Yeah, but the answer is yes.
Okay, one more student has question from the Zoom chat. So the question is, if there's some accident of the building using robot to control this kind of building collapse, and who will be responsible for the accident? Oh, this is a reliability issue.
Well, first of all, I really don't want this happen. As I'm a civil engineer, the accident happened in the building, somebody dies, that's too much. The building collapse or do happen, right? Do occur during earthquake, and you're talking about first one. I would say one is the something like the emergency control, evacuating people.
I think the citizen asked the question that if in the near future, why the building was 100% built by robot, who and then if there's some problem, accident due to this robot, this kind of the building not by human but by robot, right? And then what happened? Who is reliable? Who is what's the liability issue, right?
Well, still engineers stamp on it. That's for sure. I mean, hey, we were not talking about like there's no machine being used in the current construction site, right? Look at the window. There are tower crane, there are excavator, there are bulldozer, there are all these backhoe things. Well, they're being built. Or even the concrete pouring. There's a pump machine actually working on that. All the things, I would say, the machine being used to build the building, right? To construct the building. But nobody blame all this machine, right? If something happens and if there's a concrete falling down and something, it's always the engineer who stamped that drawing that make responsibility. That's what this the engineer, well, that's the responsibility of the engineer. That's what the engineer paid for, to take responsibility. That's it.
Maybe I ask some comment typically,
Okay.
at least in Hong Kong, right,
Uh-huh.
for those engineers who really want to work on design of the building
Yeah.
or a structural engineer or the thing,
Mhm.
they have to get license. Oh, this kind of Hong Kong IE, right? A certified
Yeah.
engineer. If you graduate from our UG program, and then actually you cannot really, you don't have this kind of authority to see. You have to pass through kind of Hong Kong IE accreditation, become this kind of charter engineer. So actually that's additional training. And then so things, of course, from the government side, most likely when the construction company finish this kind of building construction, most likely there's certain of a quality control, right? From the company and from government, they have to do the inspection about things. I don't think it will be 100% rely on all those machine and robot, right? After even human worker or this kind of robot worker finish this kind of construction, at the end of the day, there must have a series of this kind of inspection, right, and quality control. Make sure this the building can meet this kind of a building code, right? This is my own understanding. Yeah.
Sure. Yeah. So still, the engineer who got licensed and got a real stamp, and that makes these things legal. And of course, there are insurance. So there are insurance behind the engineer. So if something really happened, there are several like forensic process going on to inspect who designed or constructing some flaws, and to the forensic engineer and the lawyer and insurance, they will pinpoint on where are the problem, who gonna pay, and who gonna carry the responsibility. So there are a whole process if the accident happens. And robots, yeah, whoever use the robots, behind the robots, and will still carry the responsibility.
Yeah, I still remember, Dr. Yun, you before like 1 or 2 years ago, there's a project at Hong Kong CRC to help how to develop some kind of a machine and tool for this kind of a remote way to do quality control about those kind of right? I mean, prefabricate this kind of component module, maybe in mainland China, and then before they ship to Hong Kong, and then so there must have a way to do much more this kind of sophisticated, this kind of inspection of those kind of building component to be assembled, right, for the whole building. Of course, that's I think that's another quite important thing, right, for any kind of this kind of mechanical structure, the building or the car, right, automotive industry, anything related to this kind, they have some liability issue, right? And most likely they have some very serious kind of quality control. Yeah, and yeah, that's a quite important thing. Yeah.
That's a very good point to raise, actually. The QA/QC part is a really critical process in Hong Kong. I would say one of the challenging that this the modular construction industry facing is when they build these housing units in the factory in mainland, they really want to meet the criteria set by the Hong Kong developer, the Hong Kong contractor. Because they're cross the border, and the factory in mainland not familiar with all this regulation, all the design code, all the quality criteria. So they need inspection. So currently, Hong Kong send out the inspector to check to the factory to check manually, visually, and all the inspector they using very basic tools like the rulers or the pencil, paper, and to record everything. So the Hong Kong actually all these inspector want us to develop some digital tools like the AI camera that I mentioned, and all with some hand tools like to check the temperature, to check all the things. So in whole set, they want us to develop a whole set to help them to make this QA/QC. And this whole process we are going through actually has already the automobile, the cell phone industry, the 3C industry, they have go through all this digital inspection, auto inspection to make this mass production happen. And here in construction industry, it's just phase one, because we just start to make this modular housing to be built, construct in factory. And that's where the inspection starts going on to make this housing really like a product, to make the we need to apply the quality assurance, quality control, QA, QC process on house just as a product. So this is what our inspection group and here to develop technology for AI camera, for the ruler, digital ruler, inclinometer. Actually, we had several guys working on tools for inspection specifically here. So that's the background, and that's what we are doing. Yeah.
Okay, so I don't know if any other question for Dr. Yuan. So I hope that our students really understand this kind of activity now. Those R&D engineering activity of Hong Kong CRC, and also if some of you are interested, you can try to send email to Dr. I think that Dr. Yuan was saying. Of course, on the other hand, I don't know if some of you may want to visit Hong Kong CRC to see that robot. Maybe we can try to
sure, we can arrange that.
Every day we have some shuttle between UST to Hong Kong Science Park, because we still have some our PhD student, MPhil student, they study here and they have to work in Hong Kong CRC. So I don't know if some of you want to visit Hong Kong CRC to take a look at the real robot for construction, so that maybe we can send some survey and then try to arrange some additional time, maybe sometime, maybe next week or something. We can do some survey to see if any of you want to take a look about this kind of real robot. Any of you want to see this one? If you want, then of course I do think we can arrange. Any student want to take a look at this kind of those robots in Hong Kong CRC? I think we should be able to arrange some on-site visit. Don't worry. You will not get any big problem. It is we have but some big robot already probably is not in the Hong Kong CRC here, already in construction site or some other big city. Hong Kong CRC have a little bit smaller space, so that we cannot accommodate all the robot. But it is some, you can see some robot, and some of this to do the RA do some prototyping. If you're interested, definitely we can arrange this kind of site visit to Hong Kong CRC for you to see something. Not only here, PowerPoint presentation and video is okay, but if you see the real stuff, that would be interesting for some of you. Any of you want to think, then of course we can arrange, right? We try to look at survey and find one particular day and time, and then let our student to take a look. Yeah, I don't know. Is that possible for? Of course, not everybody. I would say only those students who really had high motivation to take a look, and maybe also try to see that what kind of the kind of job opportunity, so that we will allow selected kind of student to go to the Hong Kong CRC to see this kind of real this kind of prototyping, and also real working robot. Yeah.
Actually, I want to add one. One of the job, actually, the intern we are looking for now is really testing all the robots. So that's really a great opportunity actually to first play with the robots, and also explore the limitation and
as a feedback
right,
to our RA, or say to design the robot.
And to collaborate with other developers.
Take iteration. All this kind of robotic automation machine take iteration. Only first generation, number 2, 3, 4. So I would say maybe if some student want to help to do the testing, seeing not only on the design and prototyping. I think it's still important part of this kind of R&D for this kind of a robotic system. Yeah.
Yeah. Testing is really embedded in all the design. It's really like iteration. So while we design the EVT number 2, while EVT number 1 been testing and to give us all the flaws, that feedback, or even, hey, that broke, you need to change that. So we need to make that iterate. So that's why we want this full-time intern and working I mean, yeah, the full pace with us, right?
I see. Okay, I think we almost run out of time. So today we have really very glad to have Dr. Yuan to give you wonderful this kind of this online seminar with all this kind of very good working robot. It's not something on paper. It's we do have our very hardworking engineer, RA, and Dr. Yuan to really do things. So anyway. So I think we should thank Dr. Yuan. At least we have some way to thank our Dr. Yuan virtually. Thank you, Dr. Yuan, to give this kind of very good, this kind of online seminar, and hope some students may be interesting to find this kind of summer job at HKCRC. Okay, thank you so much. I think that's it. Okay, bye-bye. Okay,
thank you. Thank you. Bye.
Okay, bye-bye.